Alright, so now we're going to demo the related samples or the paired samples t-test if you have this for your project. So hopefully you'll use things that we've covered before on histograms and descriptive statistics to be able to help you get all the pieces you need for your final project. But we're going to revisit descriptive statistics, and we're also going to look at constructing the hypotheses, both kind of in words and in the notation terms. We're also going to then finally demo how to perform your t-test using Excel. So what I have here is what looks like data that you have for your project. You have two columns of data. We have scores before and we have scores after a weight loss treatment was administered for a bunch of males and females. So this is how much a person weighed before the treatment, and this is how much they weighed after the treatment. So for this test, the hypothesis would be about whether or not we expected people to weigh the same or to weigh different amounts after treatment. Now, as you learned about this week, hypotheses can be directional or non-directional. And a directional hypothesis is about looking at only one side of the distribution, less than or greater than. You don't care about them just being different. You want them to be different in a specific way. So in this case, obviously, if we have a weight loss treatment, we're hoping that people are going to go down. So it would make sense that this would be a directional hypothesis. Now, even though this is the case, often in statistics, because it is more conservative, that is, it's harder to achieve statistical significance, we will use non-directional or two-tailed hypothesis tests, even when conceptually we have a direction that we anticipate the difference being. Not only does this be a little more conservative and demand evidence be a little greater for us to conclude that we observe what we're looking for, it also ensures that we can see that if the results go in the way we don't expect. So what if people weighed more after than before? We would want to know that as well. And if we did a one-tailed test, we would only be looking for significance in the scores going down, not considering if they went up. If the scores went up, we would just say retain the null hypothesis. But really, it's useful to know if the scores are statistically different in either direction. So in words, I'm going to start with, okay, what is my alternate hypothesis? Now, the alternate hypothesis is basically what I expect or want as a researcher. Most typically, the alternate and the research hypothesis are going to be the exact same thing. So in this case, we might say individuals will weigh significantly less on average after completing the weight loss treatment. Now, the null hypothesis says that that's not true. So the null hypothesis would say individuals will weigh the same on average after completing the weight loss treatment. So this is the alternate null hypothesis. We could also word this as there will be no differences in weight before or after treatment, if you wanted to word it that way. Notice it's not that there's necessarily just one way to word it. It's just making sure we have the concept that the alternate expects these to differ significantly, and the null does not expect them to differ significantly. In terms of the notation, now I can't do all the symbols in Excel. We can do it in Microsoft Word to get characters like mu, but for now I'm just going to write them, kind of spelling them out. So under the alternate, what we would say is that the average difference, right, does not equal 0. That is, that the average difference between before and after, right, for this sample is a non-zero number. That is, weight has changed significantly. So we're going to make this a non-directional just because, again, it tends to be more conservative and it's the go-to. In science, we default to two-tailed tests. You have to really justify doing a one-tailed test for the most part. So on the other hand here, what would the null say? Well, the null would then say, as you learned in your other video, the null basically contains the statement of equality here. So the null would say that the average difference is 0, right? There is no difference. On average, the difference is 0. So we would have the alternate and the null hypotheses. And these are what we're going to then look to test. So the first thing we want to do is get some descriptive statistics to see what are the average differences. So what we can do is get the pre and post and then get the average difference score. So how we can do this, let's get some descriptives and let's get the actual test. We're going to do this under data, data analysis, and then what you want to use is the t-test paired to sample for means. Now you see here you need to select your first variable, okay? So we can do that as the before, and then the second variable we can select the after, and you could go in either order. You'll get the same significance result, it'll just change which one you're subtracting from the other. So depending on the order, you either subtract after from before or before from after. So all that will change is whether you have a negative or positive sign. So make sure we interpret those correctly when we're done. So the hypothesized mean difference, this is looking for what did you expect the difference to be according to the null. And we expect the difference to be 0 according to the null. So that's what we'll put in there to test. Remember, we always test our data assuming the null is true. We're asking what is the probability of observing the difference we have if the null hypothesis is true. So we're going to put our output here in this box, and we're going to go ahead and perform our test. So here is our t-test result. That has our values for us. And if we're not sure about the order that it went, you can always get the averages. So we could, for example, say, well, what was the average for our before scores, which are contained in A2 to A21? And we can copy that function across and get the average for the after scores. Now notice, we see that this goes before and after in the order that we put them, right? So we see that people weighed about 5 pounds more before treatment than they did after treatment. So compared to expecting them to weigh no different, what does our test say? So here is our t statistic. This is the first thing that we need to pay attention to. So we have our t statistic, and then we have p-values for the one-tailed and the two-tailed p-value. So doing a non-directional test, this would be the value we use to determine significance. And remember, what we're doing is checking to see if this value is less than or equal to 0.05 as the statistical convention. So what we see is that 0.0188, right, rounds 0.02, that is less than 0.05. So we would call this statistically significant. And in intro psych terms, intro stats terms, we would say then to reject the null hypothesis. So we then need to interpret this. What is the nature of the difference? And we see that people weighed significantly less than after treatment because the test is significant and the weight was lower after than it was before. So we would say that individuals weighed significantly less after treatment, a mean of 210.6, than they did before treatment. And the mean is 215.75. So there we have basically what our results mean. We have a statistically significant effect that shows differences in the direction that we kind of would have expected with a one-tailed test with the idea of less. But we tested, of course, here with a two-tailed test. It would have been significant, of course, at the one-tail. You notice the one-tail value is actually half of the two-tail value. And so it looks, if you permit the terms, more significant. This number is smaller. But, again, that's why we just typically go with the more conservative two-tailed test. So, this is what we would conclude from our analysis. Now, if you wanted to get the additional descriptive statistics to summarize the before and after scores, notice this gives you the means and the variances. If you wanted anything more, what you could do is use the descriptive statistics function we learned previously. Under data analysis, and you'd go to descriptive statistics, and then you would just select your data. So we could summarize the before, so this is our before data, and then next to it we could do data analysis to summarize our after data. So our after data is contained in the B column, so I'm changing the A's to B's, and I'm going to change the reference here to start in F, and OK, and this is our after data. And so here again we have the means that we saw. You now also get medians if you want them, standard deviations, and a bunch of other statistics about the distributional characteristics of the pre and post weights. All right, so that's what you could do to do the hypothesis testing process for repeated or related samples t-test.